NASA's Kepler Space Telescope was a remarkable piece of engineering, but it had a job that was, let's be honest, kind of boring. It was built to do one thing: stare at a single patch of sky and its 150 stars without blinking for years. Its whole mission was to find the predictable. It hunted for tiny rhythmic dips in starlight, the telltale sign of a planet passing in front of its sun. And for years, that's exactly what it did. It was a planet-finding factory, churning out thousands of worlds with a steady, reliable rhythm. But in 2015, out of all those thousands of stars, Kepler found one that didn't play by the rules. A star that dimmed so much, and so bizarrely, that it broke every model astronomers had. This is the story of that star, CAC 8,462,852. It's a story of a mystery so strange it forced us to consider an idea that feels more like science fiction than actual science: a giant, alien-built megastructure. To really get how weird this star is, you first have to understand what's considered normal. Kepler's main strategy for finding planets is the transit method. Picture a streetlight down a long road. If a moth flutters past the light, the bulb will dim just a tiny, barely noticeable amount. If that moth is flying in a predictable circle, you'll see that same little dip over and over, like clockwork. A planet orbiting a star is that moth. It causes a slight, regular dip in brightness, usually less than 1%, and it happens on a perfect schedule. It's a subtle but reliable cosmic clock. For years, Kepler beamed mountains of this data back to Earth so much that astronomers couldn't possibly sift through it all themselves. So, they did something brilliant. They asked for help. Through a project called Planet Hunters, anyone, citizen scientists from all walks of life, could log on, look at graphs of starlight called light curves, and flag anything that looked like a planet. They became partners in one of the biggest astronomical quests of our time, and it was these citizen scientists who first spotted KIC 8,462,852, a star about 1,500 light-years away. They saw a light curve that was anything but normal. It wasn't the gentle repeating dip of a planet. It was wild, chaotic, and unlike anything anyone had ever seen before. The data from KIC 8,462,852, which everyone quickly started calling Tabby's star after the lead astronomer Tabitha Boyajian, was just baffling. The star was seeing huge drops in its brightness, but with absolutely no pattern. These weren't the tiny 1% dips of a big planet. The starlight was plummeting by 5%, 15%, and at one point, an unbelievable 22%. To block that much light, whatever was out there had to be enormous, 1,000 times the area of Earth. For perspective, a planet the size of Jupiter only blocks about 1% of this star's light. So what could possibly be that big? That was mystery number one. Mystery number two was the timing. The dimming events were completely random. They'd last for days or weeks, then the star would go back to normal, with no rhythm at all. This wasn't a single object in a stable orbit. It was something else, something messy. Boyajian's team started working through every natural explanation they could think of. Could the star itself be the problem? Some stars are variable, meaning they naturally pulse and change in brightness. But Tabby's star is a mature, F-type star, a type just not known for this kind of behavior. Plus, its color didn't change when it dimmed, which ruled out most kinds of stellar weirdness. Okay, so, if it wasn't the star, it had to be something orbiting it. What about a massive planetary collision? Two planets smashing into each other would create a giant cloud of debris that could block the light. It's a cool idea, but an event that catastrophic would also kick up a ton of heat. All that dust and rock should glow brightly in infrared light. When astronomers checked, they found nothing. No infrared glow. The collision theory was out. The next best idea, a giant swarm of comets. Maybe another star flew by and knocked a ton of comets from the outer edges of the system toward the star. As they got close, they'd break apart and release huge clouds of dust and gas, blocking the light in a clumpy, irregular way. This was plausible, and for a while, it was the frontrunner. But it had a serious numbers problem. To block 22% of the star's light, you'd need hundreds of thousands of gigantic comets. Possible? Maybe. But it felt like a huge stretch. Every natural explanation they tried just didn't quite fit. The data was simply too strange. They had ruled out the ordinary, the plausible, and even the wildly speculative. With the list of natural causes getting shorter and shorter, one astronomer decided it was time to think about the impossible. This is what a real scientific mystery looks like. It's a journey into the unknown where every new clue just brings up deeper questions. If you're enjoying this deep dive into the cosmos and want more stories that stretch the limits of what we know, hit that subscribe button. We've got a lot more of the universe to explore together. Enter Jason Wright, an astronomer from Penn State University. He'd been working on a project exploring how we might find signs of an advanced alien civilization, not by listening for radio signals, but by looking for massive engineering projects. When he saw the data from Tabby's star, it looked eerily similar to a concept from theoretical physics, a Dyson swarm. First proposed by physicist Freeman Dyson, it's a thought experiment about a civilization so advanced that it needs more energy than its planet can provide. To get it, they might start building a network of huge solar collectors in orbit around their star, capturing its energy directly. This collection of habitats and power stations is called a Dyson swarm. From far away, a star being slowly surrounded by something like this would look, well, really weird. Its light would be blocked by these massive orbiting structures. And if the swarm was still under construction, with oddly shaped pieces being moved around, it would cause deep, random, and unpredictable dips in the star's light. It looked almost exactly like the light curve from Tabby's star. Wright, Boyajian, and others published a paper outlining their findings. They were incredibly careful, laying out all the natural ideas that failed. Then, as a final possibility, they presented the megastructure hypothesis. They were clear. Aliens should always be the very last thing you consider. But as Wright put it, the data was so strange that the unnatural explanation was one of the few that actually fit. The idea was electric. It lit up the public's imagination and made Tabby's star the most mysterious star in the universe. The SETI Institute even aimed its powerful radio telescopes at the star. Listening for any intelligent signals, they heard only silence. The alien megastructure idea was thrilling, but it had one big problem: Occam's razor. That's the principle that the simplest explanation is usually the right one. And an alien civilization building a megastructure is pretty much the opposite of simple. Science needed more data. The problem was, the Kepler telescope's mission had ended. To keep watching the star, astronomers needed dedicated telescope time, which is hard to get. In an amazing show of public fascination, Tabby Boyajian launched a Kickstarter campaign. Over 1,700 people chipped in more than $100,000 to buy that precious telescope time. And in 2017, the wait paid off. The star started dimming again. This time, astronomers were ready. A whole network of telescopes around the world watched it happen, not just in visible light, but across the full spectrum, and they found the smoking gun. When the star dimmed, it didn't dim evenly across all colors. More blue light was being blocked than red light. This is the key clue. Any large, solid object like a planet or a giant alien solar panel would block all colors of light equally. But a cloud of fine dust doesn't. It's the same reason our sunsets look red. Dust and particles in the atmosphere scatter the blue light, letting the red light pass through. Whatever was blocking the star's light was filtering it. The culprit wasn't an alien megastructure, it was dust. So, mystery solved, right? Well, not exactly. We know what is blocking the light dust, but we still don't know why the dust is there. The leading idea is that we might be seeing the shredded remains of an exomoon, a moon ripped apart by its planet, leaving a trail of debris. Another theory is a stellar indigestion event, where the star ate a planet and is still burping up the leftovers. And to make it even more complicated, there's a companion star nearby whose gravity could be stirring everything up. What makes the story of Tabby's star so incredible isn't the idea that it might have been aliens. It's the journey. It's a perfect example of science in action. Faced with a truly deep mystery, scientists and the public worked together. They threw every idea they had at the problem, from the simple to the extraordinary. They tested each one rigorously, and in the end, they found a natural explanation, even if it's one we're still trying to figure out. Tabby's star didn't give us aliens. It gave us something just as valuable, a reminder that the universe is still full of things that can blow our minds and spark our collective imagination. It proved that sometimes the most exciting discoveries aren't the answers, but the incredible questions they make us ask. So, what do you think is causing the mysterious dimming? A shattered moon? A cloud of comets? Or is there another twist in the story? Let me know your theories in the comments below. Thanks for watching.